So today, as you know from class, we're going to keep working in Chapter 4, Section 2. Now, Chapter 4, Section 2 has lots of information and lots of different kinds of equation solving in it. We're going to work with the distributive property ones, or equations that have parentheses, found on page 206 through 208. So the steps involved in this kind of equation solving. First, get rid of the parentheses. Distribute what's outside the parentheses by multiplying. Then always look to combine like terms if possible. Then it comes down to usually a two-step equation where we're going to look to undo the adding or subtracting and then the multiplying and dividing. So it's going to look like, as we get towards the bottom, like the equations that we did today in class. So you can do method 2, and I'm going to show you both ways. Method 1 says multiply, distribute, use that distributive property. Method 2 says, well, instead of multiplying, why don't we divide first on both sides of the equation? Sometimes it's easier to do method 2 instead of doing method 1, and sometimes it's not. And I'll point some of those out to you. I'm working on pages 8, 9, and 10, and I'm not going to do all of the examples. I'm going to do most of them, but not all of them. So this example number 1, I'm going to do both ways. This is the method 1 way first, where I'm actually going to distribute that 5 to what's inside that parentheses. So 5 times d gives me 5d's, and 5 times negative 2 is negative 10. So I have the equation 40 equals 5d minus 10. I have no like terms here to combine, so I'm going to undo my subtraction of 10 by adding 10. And yes, you have to balance this on both sides of the equation. Add 10 to the right member, add 10 to the left member. I'm going to cancel. I get 50 on the left, has to equal 5 times what? I know that you know that answer is 10. However, you have to show the opposite operation of dividing by 5 on both sides. We're showing all the steps. We're not answering these in our head. We get 50 divided by 5 is 10 equals d. I'm going to do a quick mental check here, okay, and put it into this equation. Is 10 the answer? Well, 5 times the quantity, 10 minus 2. Well, I know what that value is, so 5 times the quantity, 10 minus 2. I know d now, so I'm not going to distribute 5. I'm going to do the correct order of operations. Do the parentheses first. 10 take away 2 is 8. 5 times 8 is 40. Oh, that's the answer, 40. Yippee, I've got the right answer. I did a mental check. Yes, I might have written something out up here, but I did do a check. Go on to the next equation. Well, this is same equation doing method 2, where it says undo the division or multiplication first. Remember, whatever you do to one side of the equation, you have to do to the other. So instead of distributing this, which is the multiplying, I'm going to do the opposite of that first. I'm not going to distribute, and I'm going to divide both sides of the equation by that 5. Because 40 does divide by 5 evenly. So I get a nice whole number here. I get 8. 8 is equal to, those 5's cancel, d minus 2. I don't need the parentheses anymore. 8 is equal to what number minus 2? Oh, well, add 2 to both sides. I know you know the answer is 10, because we've already done this problem, but we are going to show the balancing of 2 on both sides, and we get 10 equals d. D's on the right side, leave it over there on the right side. 10 is on the left side, leave it on the left side. 10 is equal to d. The formal check, which I did a little mental check already, the formal check looks like this. You write the word check. You write the original equation. 40 is equal to 5 times the quantity d minus 2. I think d is 10, so I'm going to replace that or plug it into the equation. Okay, I do the order of operations. 10 take away 2 in the parentheses first is 8. 5 times 8 is 40. 40 equals 40. Yippee. I have a balanced equation at 40 when my answer is 10. That is the correct solution to this equation. Number 2, I'm going to do it both ways. First method, I'm going to distribute first. Negative 2 times x is negative 2x. Negative 2 times negative 20 is positive 40. And that equals 10. So I have two operations. I have multiplying x by negative 2, and I have adding 40 to my x. I'm going to undo the adding first. Subtract 40 from both sides, and I get negative 2x equals 10 take away 40, different sign, subtract. 40 take away 10 would be 30. Take the sign of the larger absolute value, negative 30. 10 take away 40 is negative 30. Dividing by negative 2, which is the opposite of multiplying my x by negative 2. Cancel those. Yes, negative 2. X equals negative 30 divided by negative 2, positive 15. And you know you don't have to write the positive sign. 15 is the solution. That's doing the distributive way first. Well, I look at my equation. Here's doing it method 2. Will 10 divide by 2? Yes. And I'm going to divide first by negative 2. So I get just the parentheses, x minus 20, which no longer needs the parentheses, by the way. I've removed the parentheses because I've removed the multiplication by doing the division. 10 divided by negative 2 is negative 5. Now I have a single operation, subtraction of 20 from my x. Okay, the opposite is to add 20. So x equals negative 5 and positive 20, different sign, subtract. 20 take away 5 is 15, keep the sign of the larger absolute value, which is positive 15. Check. Always want to check to make sure your equations are correct. So negative 2 times the quantity x minus 20 equals 10. Is it true when you put in 15 for your value of x? Do you get a true statement? 15 take away 20, we have to do the order of operations correctly here. Do the parentheses first. 15 take away 20 is negative 5. Negative 2 times negative 5. So I'm showing the computation step here. This does not have to be in the check. I could have just done this all in my head. 15 take away 20 is negative 5 times negative 2. Negative 5 times negative 2. Oh, that's 10. 10 equals 10. Yippee! Right answer. The answer is positive 15, and that will give me a balanced equation of 10 equals 10. Now, from this point forward, I'm not going to do it both methods. You can choose. I may do it both methods, but you can choose. I'm going to skip question number 3 and go to question number 4. Question number 4 really does have a parentheses in it because the fraction line here is a grouping symbol. What's in this numerator is really being implied as being inside of parentheses. So you wouldn't think that that's a parentheses, but remember I taught you that grouping symbols are parentheses, hard brackets, fraction lines, and the absolute value symbol. Those are all grouping symbols, or what we call parentheses in our PEMDAS. So those are all kinds of parentheses or grouping operations. So the fraction line is a grouping operation. So I have dividing by 2 and a grouping operation. Remember, we do our PEMDAS in reverse, and I call it GERMDAS, as you know. Grouping symbols, exponents and roots, multiplying, dividing, adding, and subtracting. Well, I have division here. If I'm going to do this in the reverse order, well, I can't undo that subtracting, subtract 8, because that 8's being divided by 2, so I can't do that, because this is a grouping symbol, and that's division. So I'm going to undo that division first, and last undo that grouping symbol. If I do PEMDAS in reverse, I have a grouping symbol in my numerator and division in this problem. So the opposite of dividing would be to multiply both sides by 2. So times 2, and yes, I'm multiplying up. It's really 2 over 1. I'm sorry, I'm writing over that example number 4 there. 2 divided by 2, those cross cancel when you multiply there, multiplying by 2 on the left side. And you just have negative 4x plus 8 is still remaining on the left equals 2 times 20, which is 40. Now I have two operations. I have multiplying my x by negative 4 and adding 8. Now I'm going to do that subtraction of 8. Because it's not 8 divided by 2 anymore. It's just the whole number 8. And I cancel those 8s out, and I get negative 4x equals 32. Dividing by, same thing that I'm multiplying by, negative 4, because negative 4 over negative 4 equals positive 1. Yay, that's what I want, positive 1x. We don't write the 1, we know that. Have to divide by negative 4 on the other side, so my positive 1x equals 32 divided by negative 4 is negative 8. So my example on that side, the answer is negative 8. I'm going to check this one. Check. Here's the equation already written or typed in for me. I believe the answer is negative 8. Oops. Divided by 2 equals 20. Move that down a little bit. Equals 20. So I have negative 4 times negative 8 is positive 32. Positive 32 plus 8 is 40. 40 divided by 2 is 20. Oh, I do get 20 on this left side. Doing all those operations, negative 4 times negative 8 is positive 32, plus 8 is 40. Then dividing by 2, I get 20. 20 equals 20. Yippee. Tough question. I'm also going to do example number 5. 1/5 times x minus 13 equals negative 7. I could distribute that 1/5. But then I have 1/5 x and 13/5. Ugh, I don't want to do that. I don't want to do the distributive way on this one because it actually makes it a little more complicated. I'm making myself give myself fractions. I'm going to do the opposite of multiplying by 1/5, which is multiplying by 5. Because dividing by, right, the opposite of multiplying by 1/5 would be dividing by 1/5. We don't divide by fractions, we multiply by the multiplicative inverse, which would be 1/5, keep it, change it, and if I was going to flip this over, oh, it's like multiplying by 5. So yes, I am going to do multiplying by 5 there to undo this multiplying by 1/5. Those 5's cancel, remember, that's like having 5 over 1. So I have 1 times the quantity x minus 13. Well, 1 times anything is just that anything. I don't need to put that 1 outside there. I'm just going to have x minus 13. Well, I have to multiply by 5 on the other side of the equation as well. So x minus 13, what number minus 13 equals negative 7 times 5, which is negative 35. I have a one-step equation now. Subtracting 13 from x. The opposite is adding 13. I'm going to add 13 to both sides. And I get x equals, ooh, different sign, subtract. Take the sign of the larger absolute value, negative 22. I'm going to check this equation, write the word check. There's the original equation typed for me. If it wasn't there, I would have to write it. 1/5 of negative 22 minus 13 has to equal negative 7. Order of operations says do what's in the parentheses first. Negative 22, take away 13 more, or negative 22 combined with negative 13. Yep, I would have to keep that up. That is negative 13. That's negative 35. 1/5 of negative 35 is that negative 7. Well, if I put this guy over 1, negative 35 over 1, because that's what it is, these 5 goes into that 35 7 times, yes, it's negative 7. So 1 times negative 7 is negative 7. 1 and 1 on the denominator, oh, I don't have to write it over 1. So yes, 1/5 of negative 35 is negative 7. Hey, that's what I had on the right side of the equation. It's now balanced. Yippee! Got the right answer. Negative 22 is the answer to this equation, which balances it at negative 7. Negative 7 is not the answer. Negative 22 is the answer, or what's called the solution of the equation. I'm going to go to the next page, on page 10, and I'd like to go all the way down to number 9. Number 9, distributing 4/10. It's kind of like that 1/5 one. If I distribute 4/10, I'm going to give myself more fractions in the problem, or more decimals, excuse me, more decimals in the problem. 4/10 will divide into 4 and 4/10. 4 and 4/10 will divide by 4/10. I'm going to divide. I'm going to do method 2 here. I am not going to distribute this. I'm going to do the opposite of that multiplication, which is dividing by the 4/10. I think this is going to make it simpler, faster. That's why I'm going to do this. So those cancel. And the only thing I have left on the left side is x plus 7. 4 and 4/10 divided by 4/10. 4 and 4/10 divided by 4/10. Well, you can't divide by a decimal. Move it over. Move it over. So you're really doing 44 divided by 4. And I could have done that right here. I'm really doing 44 divided by 4. Oh, I know what that is. That's 11. What plus 7 equals 11? I know the answer is 4. I'm going to show the work, though, because that's what we're doing here. We're all about balancing the equation and showing our work. Yes, x equals 4. The check would look like this. Write the word check. 4/10 of the quantity 4 plus 7, does it equal 4 and 4/10? Well, that's 11 in that parentheses. Is 11 times 4/10 4 and 4/10? 11 times 4/10. You get 44. Oh, put the 1 decimal. Oh, yes, it is. 4 and 4/10 equals 4 and 4/10. Yippee. Right answer. Number 10. I'm going to, oh, it's not a distributing problem. It's not a fraction problem. It's got a decimal in it. It's got integers in it. I have multiplying my x by negative 4/10 and adding 1 and 2/10. Well, the opposite is to subtract 1 and 2/10 first. Line up my decimals here. That's really negative 1.0. I'm going to cancel that out. Negative 4/10 of x equals, same signs, add and keep, negative 2 and 2/10. Negative 2 and 2/10. The opposite of multiplying by negative 4/10 is to divide by negative 4/10. 2 and 2/10 divided by negative 4/10. 2 and 2/10 divided by 4/10. Yes, they both have negatives. So I know my answer is going to be positive, which we don't have to show that. My division, can't divide by a decimal. So 4 goes into 22 5 times, would give me 20. Subtract, annex is 0. Bring that down. And I have 4 going into 20. Got to put my decimal up into my quotient there. 5 times. So my answer is 5 and 5/10. Positive 5 and 5/10. And if I mentally checked this, well, I probably can't mentally check this. What's 4/10? Maybe I can. Times 5 and 5/10. Ooh, negative 4/10 times 5 and 5/10. That's 4 times 5 is 20. Carry that 2. 4 times 5 is 20. I get 1, 2. I get negative 2 and 2/10 plus 1 and 2/10. Does that equal negative 1? Different sign, subtract. Oh, yes, it equals negative 1. I didn't do the full check. I didn't write the word check, I guess is the only thing I didn't do there. But that is the correct answer. So that's it for today. There's some other examples on the pages if you want to try a couple more on page 9 or 10. and see what you can do. You can check in with me tomorrow. We'll talk about this tomorrow.